Calorimetry. Using calorimetry to find out how much heat given out by a reaction by measuring a temperature change. So using calorimetry to find out how much heat is given out by a reaction by measuring a temperature change. Specific heat capacity of water, amount of heat energy it takes to raise temperature of 1 gram of water by 1 Kelvin. I just thought it'd be good to include since it is a definition that I struggle with. So amount of heat energy it takes to raise temperature of 1 gram of water by 1 Kelvin. Finding the enthalpy of combustion of a flammable liquid, we need to first things first, but to find enthalpy of combustion of flammable liquid, burn it in a calorimeter. As the fuel burns, burning a calorimeter as the fuel burns, it heats the water, work out heat energy absorbed by the water. Ideally, all the heat given out by the fuel as it burns would be absorbed by the water, therefore it would allow us to work out enthalpy of combustion exactly, but it won't. When you burn a fuel, if it's in complete combustion, less energy given out. Flammable liquids are volatile, use fuel to evaporation. And here's all your equipment. You got water, stirrer, your thermometer, your combustion chamber, your fuel, reactants, air, and that. Now, using a graph to find an accurate temperature change. We use a graph of results to find an accurate value. During the experiment, record the temperature of the mixture at regular intervals beginning a couple of minutes before you start the reaction. We want to plot a graph of results. Draw two lines of best fit. One through the points before the reaction started, one through the points after the reaction started. Extend both lines so they both pass the time when the reaction started. So that's really important. Extend both lines so they both pass the time when the reaction started. The distance between two lines at the time the reaction started before any heat loss is the accurate temperature change for the reaction. So you can see an example here. Draw a straight line there, and then just before the reaction started, extend both lines so they both pass the time when the reaction started, and then that distance is your accurate, between the two lines at the time the reaction started is your accurate temperature change for the reaction. Using calorimetry to measure enthalpy changes in solution. You can also using calorimetry to measure enthalpy changes in solution, for example, neutralization, dissolution, dissolving, or displacement. Neutralization, dissolution, displacement. Add known volume of acid to an insulated container and measure the temperature. Add a known volume of alkali and record the temperature of the mixture at regular intervals over a period of time. And we also want to stir the solution to ensure it is evenly heated. Find the temperature change for experiment using the graph method, therefore allowing us to work out the enthalpy change for the reaction. And calculate enthalpy change for reactions happening in solutions, for example, neutralization, dissolution, displacement. If you mix two solutions, you need to include the masses of both. And in order to find out the energy change per mole of reactant, we need to use moles equals concentration and the units moles per unit cubed times by volume dm cubed.